Our sun is insanely massive. Want some proof? Well, 99.86% of all of the mass of the solar system is in the mass of the sun. In particular, hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks that threaten to damage their spacecraft. Sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that a chance of collision is next to nothing. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. And it's another thing that puzzles astronomers. After all, Mars isn't a planet with active plate tectonics. On the surface of Jupiter, there's a weird region that's called the Great Red Spot. Recently, astronomers have concluded that this spot is actually a storm that has been raging on the planet for centuries. But some 20 years ago, scientists noticed that the red region started to shrink. Nowadays, it's just half the size it used to be. And still, the spot is 1.5 times bigger than Earth. While looking up at the stars through your kitchen window, you ask yourself, could you send pizza to space? And more importantly, could you still eat it if it came back? These are some mighty important questions. Okay, focus. How are we going to send the pizza to space? Given that NASA's first space shuttle cost roughly $49 billion, I don't think they'll allow us to borrow a rocket ship for the day, since they may have, more important things to do. Without our rocket ship, we won't be able to get the pizza that high, or to travel at that speed. Okay, fine, they can keep their rocket. I'm happy with my amazing weather balloon, which, by the way, will still get us a third of the way to space, bringing us to the area known as the edge of space. Given that the atmosphere up there is so thin, about 1% of the pressure at ground level, it's really not that bad of a substitute for actual space for this test. I was never comfortable with being that far away from my dinner anyway, so this works much better for my food abandonment issues. To ensure we could find the pizza once it landed, we attached radio trackers to it before launching. These send a signal with a GPS position to the ground, which is then put on a map for us to chase, giving us a good idea of where the pizza will be found. Oh man, I love technology! And just like that, the moment has arrived. We found our pizza intact, and after some moments of passionate hugging and loving strokes, I'm ready to take a bite. So, was the wait worth it? How does it taste? And can you eat it? Yes, you can. But the taste? Not that great actually. And despite mentioning it earlier, I forgot to bring my microwave. The crust's been frozen from the frightening temperatures experienced on its journey. And I actually mean frozen. The bread itself has an icy middle. But before we can even discover this, we'll notice that when we go to rip a piece of the pizza off, it doesn't tear as normal. Instead, it snaps off, as if we've just broken a piece off a twig. We can even hear a clicking noise. My warm, soft bread is no more. You'd be better off keeping this for dessert, in the event you run out of frozen ice cream. On second thought, let's just throw it in the trash. Nonetheless, it's pretty cool that we were able to send this garlic bread to the edge of space and still end up eating it, right? We all know the Earth has one moon. But there are 2 more asteroids, 3753 Cruithne and 2002 AA29, locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet, which is why it's looking like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one follows a horseshoe orbit around our planet. Its specific path brings this asteroid closer to us every 95 years. Why doesn't the atmosphere of our home planet vanish and disappear into the vacuum of space? Even though we can't see them, the gas and vapor molecules that our atmosphere consists of all have mass. As such, all of these molecules feel the gravitational pull of the Earth, just like we do. They could escape, true, if they had enough energy. For instance, if our planet was closer to the Sun, the atmosphere would be hotter and its molecules could get away easier. But the Earth, fortunately, is just at the right distance from the Sun and has exactly enough mass to keep its atmosphere in the same place. A recent study claims that the Moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the Moon's surface and further into space. For several days each month, the Moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full Moon's diameter. You won't believe it, but the Moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the Moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Turns out there are plenty of planets in the universe and even in the Milky Way galaxy that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface, there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Mars quake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Mars quakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight, they're gonna let it all hang out. Or something. Our Moon could be hiding way more pockets of water than scientists used to think. Its surface has something called cold traps. Those are areas that are in permanent shadow. If you could stand near one of the Moon's poles, especially the South Pole, you'd see such shadows all over the place. There are tiny cold traps, and there are hundreds and thousands of bigger ones. These regions are in eternal darkness, and might have even gone without the slightest ray of sunlight for billions of years. And now, scientists think they're hiding much more than we thought, including small patches of ice, no bigger than a penny, but still, something astronauts could use to drink or for their rocket fuel. The majority of the water could be stored in glass or somewhere between grains on the surface of the Moon. One theory says a huge part of the lunar surface could have the capacity to store water, but no one can prove it until someone goes there in person or sends rovers that would dig under the surface. The Moon is not entirely white and devoid of color. Apollo astronauts that landed there in 1969 said the Moon was a bit brownish. Later studies showed some dark lunar areas display hints of brown and blue.